Algebra 2 students, let's learn how to write equations of composite functions. In our last assignment, we learned what composite functions were. So remember, in a composite function, the output of one function is used as the input of the next function. There were two different types of notations that we learned. So the first one using parentheses. Both of these are read as f of g of x. What this means is we evaluate that inside function. So we're going to evaluate g of x, and then we're going to put that in f of x and evaluate it. So when we work with composite functions, we work from the inside out. So that means the far right, and then expand further out towards the left. Now, in the last assignments, we did composite functions where we were evaluating. So we put in a particular number, we got a number as an answer, and then we put that into our outer function. This time, however, we're going to keep these as expressions. So we're going to still have variables. So what we're going to do is we're going to take what was x in the outer function, and we're going to replace that with the actual expression from the inner function. Okay, we can't evaluate the inner function and get a number, but we're still going to substitute that in. Let's look at a couple examples. In this problem, we are given two functions. F of x equals x minus 2. G of x equals 5x plus 3. We want to write the equation for the composite function f of g of x. First, start by identifying what is the inner and the outer. Okay, so g of x is my inner function. That means I'm going to replace that in the outer function. So here's my outer function. F of x equals x minus 2. Now remember, we said we're going to take the original function from the inside and we're going to replace that in where x was. So in other words, I could write this. F of g of x is going to equal, I'm going to leave a big blank here. That's going to be my x minus 2. Now instead of x, I'm going to fill in the information from that first function, f of x plus 3. And then I want to combine like terms and simplify. I have plus 3 minus 2, so that means that f of g of x is still going to equal 5x plus 1. Do another example. Here we're given the equations f of x equals 3x minus 4, g of x equals x squared plus 6. Again, we want to write an equation for f of g of x. My inside function is g of x, so that's what I'm going to substitute into the f of x function. So I'm just going to start by rewriting my f of x function. F of x equals 3x minus 4. Okay, that x is what's going to be replaced. So I'm going to write again, f of g of x is going to equal 3 times whatever minus 4. So instead of x, I'm going to substitute in that function, x squared plus 6. Now be careful here. That whole thing is x. So I'm going to need to use parentheses. So instead of 3 times x became the function g of x. So x became 3x squared plus 6. Now remember, we know how to simplify this. We're going to distribute. So the 3 that is outside the parentheses is going to be multiplied in. So f of g of x will equal 3x squared plus 3 times 6 is 18, and then still that minus 4. I can simplify that down. Combining my like terms tells us that f of g of x is going to equal 3x squared plus 14. We're going to do a couple more. Sometimes these can take a while to get the hang of. Also remember that we can use different letters for our composite functions. So we're given the function h of x equals x over 3 and g of x equals x squared. We want to write the equation for h of g of x. So different letters, but again, start by identifying what is your inner and outer. Okay, so g of x is my inside. So I'm going to put g of x into the h of x function. Okay, h of x has an equation of x over 3. So h of g of x is, instead of x, that's where I'm going to replace my g of x equation. And it said that was over 3. So g of x in this case is just x squared. So nothing to simplify down there. My composite function is x squared over 3. And our last one, again, starting with the functions h of x equals x over 3, g of x equals x squared. Here I use the different notation, but this is still read as g of h of x. In this particular problem, h of x is our inside. We're going to put the h of x expression into g of x. G of x equaled x squared. To find g of h of x, I'm going to replace x with the function for h of x. So I just made my box and then left squared. Inside that box, I'm going to write x over 3. That's the expression for h of x. Now again, we're going to be careful when we rewrite this. Use our parentheses because that whole thing needs to be squared. So we could leave this as g of h of x equals the quantity x over 3, the whole thing squared. We haven't reviewed exponent rules yet this year. You might remember that the exponent outside actually applies to everything inside. So if you wanted, you could write this as x squared over 9, 3 squared on the bottom. And that is how we write equations of composite functions.